Good morning, everybody, and thank you for coming for our scientific workshop.
The topic is next generation wireless edge networks.
What are the things that we really need in our next generation kind of wireless edge networks at the physical layer? A lot of the demands and desires right now are for energy consumption, reduced power consumption, reduced costs of devices, better latency, throughput, and quality of experience for different apps, better spectral efficiency and device density, and we need to scale from hundreds of millions to many billions of devices at this point. And we need resiliency and reliability. So how do we get there? And how does machine learning play into this?
I was thinking, okay, next generation wireless edge networks, what will be the problems which we'll face? What are the challenges we need to address? And what a higher challenge, actually, than putting all of our nice laboratory equipment into the wild.
Okay, so SS run scalable over native CUDU solutions for everyone. And by everyone, I probably don't mean your grandmother, but there's quite a few use cases that we cover, we think, and it should be good.
Climate change, geopolitical problems, that is something where we have to find solutions. And communication networks have an answer to most of them, if not all of them. And I will tell you why this is. There are different technologies that goes from quantum computing and communication, artificial intelligence, human-machine interfaces, post-Shannon robotics, DNA and molecular communication. These are things that we are currently doing research on.
Thank you for having me. My name is Marojevic. I'm with Mississippi State University. And I'm going to talk about our project called OpenAI Cellular. Especially, I think, personally, that the upper mid bands are going to play a very important role in beyond 5G networks.
And MAKI stands for Multi-Mechanism Adaptations for the Future Internet. The current internet consists of many different protocols on different layers and designed for specific use cases and applications. We call all these protocols mechanisms. There are different mechanisms for different purposes. But the problem now is the environment or the context in which we use these might change. In this graph, we have on the x-axis the environment, on the y-axis the quality. And one mechanism might be optimized for a specific environment where it achieves a very good quality. But the environment or the context in which we use this application might change because we move or many more people share the same resources, so the quality degrades. But there could be another mechanism that would enable the application to perform better in this new environment. But it's a totally different mechanism. And there might be a gap between these two mechanisms. So we can find another mechanism to bridge this gap. And we want to have seamless, automatically generated transitions to move between these different mechanisms to achieve an overall high quality for future applications.